So we're given the diagram, and ultimately we need to find the force in every member. So step 1, statically determinate structure. We'll draw the external free body diagram, so we'll treat it just as one bulk structure, freeing it from how it's connected, in this case, to the ground. So it's important to be labeling our free body diagrams now, because before we only ever had one. We're now going to have several, so we want to keep track of what picture is associated with which equations. So I'm going to call this free body diagram Roman numeral 1. And this is going to be the external picture of what's happening. Right, so I have my entire truss. I have a 450-pound force acting at point D. And now I'm freeing it from its external supports. So that roller at A, I'm going to replace with that one force I'm going to call AY. And that C, I'll have a CX and a CY I'm going to assume are positive. I'm going to use the same coordinate system for all of my pictures. So I'm only going to draw the XY one time, but I do need it at least that one time. All right, so I have 3 unknowns, which we predicted just based on 1 pin and 1 roller. So three unknowns. It's a rigid body problem, so we'll be able to get 3 equations out of this first picture. And again, it's just like what we saw previously in Chapter 5. So we're going to be jumping between free body diagram and equations, although you could draw all of your free body diagrams and then write all of your equations. But if we're doing it by hand, I think this will be a little bit easier to do. All right, so I'm going to solve for my 3 unknowns first. So if I sum my forces in the x direction, I now want to indicate what picture I'm referring to. So I have a superscript Roman numeral 1 here to say it goes with free body diagram Roman numeral 1. So looking only at this picture, if I look at what's happening in the x direction, I have negative 450 pounds plus CX. And this is going to be my equation 1. So we can take equation 1 and we can solve it. We can find that CX, since it's the only unknown in equation 1, that CX is going to be positive 450 pounds. If we then sum forces in the y direction, in picture 1, we'll have AY plus CY. And that's all the forces that act in the y direction. Right, so equation 1 I've used. Equation number 2, I have 2 unknowns and 1 equation, so there's nothing I can do with it at the moment. So I'll move on to equation 3, summing moments about a point. So what's the easiest point to use for picture number 1? Right, the pin at C. So if I use C, then my moment around C is going to be 450 times 4 feet minus 8 AY. So since I chose C to take the moment about, I can find that AY is going to be a positive 225. And then I can put that into equation 2 and find that AX is negative, CY. There it is. CY is a negative 225 pounds. So if this were a problem from Chapter 5, we would be done. We found the 3 reactions, and that's all we were interested in. But now, we want to find the force in all of the members. So far, we found the force in no members. All we found were the reactions, but we need these to get to where we need to go, find the forces in the actual members. Questions so far? This is exactly what we've done before. So what's new is now to find the forces in the members using method of joints. Now what I do is I look at what is happening to the pins. the pins in this problem being A, B, C, and D, and modeling what's happening to each pin, now we'll be able to see the effect that the members have on the individual pins. So since we're doing this by hand, we want to look for, it's preferable to start with pins that have the fewest things happening to it. So for example, the pin A is attached to member AD and member AB, and it's attached to the roller, which we've already done the work to solve what the roller is doing. So I would suggest starting with A rather than D or B. D is connected to 3 members, B is connected to 3 members. Remember, we can only get 2 equations out of every picture, so if we start with the easier ones and then work our way to more complicated ones. Right, so I'm drawing another free body diagram that I'm going to call A. And this is modeling what's happening to the pin, to pin A. So what forces affect pin A? Right, so AY affects the pin. We said it was up in the first picture. It turned out that it was positive. So right, we're just going to copy that exactly. So 225 pounds up. That's from the roller acting on the pin. Yeah.
If we assume incorrectly on the first one, do we correct it on the second one?
I recommend we do, and we'll see that on the last pin that we do what the difference is. So our assumption was right, so we don't have to worry about it. Say it was up, and it was up. Yep, so we'll get to that when we model C. All right, what other forces act on the pin at A? Yeah.
Force in AB.
Right, so the member AB is pulling or pushing potentially on the pin also. So the way we model it, part of our assumption of trusses is that the force in members act only along its length. And for our analysis or for our solution, I'm going to always be assuming tension. So I'm assuming that the force in AB pulls it to the right. So if it's in tension, that means that the forces are always coming out from the pin. So FAB, I know it has to be either left or right because it's along the length of the pin. I'm assuming tension, so it's to the right. And then what else affects the pin at A? Yeah.
Force AB.
Right, so the force in AD. So again, I'm assuming tension. This makes a 1, 1, √2 triangle or a 45-degree angle. So FAD, I'm assuming is up and to the right at 45 degrees from the horizontal. All right, so again, we started at A. If we look at the picture, there's 2 unknowns in it, so we should be able to find both of them. So now we look just at picture A, and we can sum forces in the x direction. And if the whole truss is in equilibrium, every piece of it is, including every pin. So from picture A, summing forces in the x direction, we're going to get FAB plus 1 over √2 FAD. We've already used, I'll keep track here, we've used equations 1, 2, and 3, so there's nothing else they can tell us. We have 2 unknowns, 1 equation, so we can look at the y direction in A. So in the y direction, we'll have the positive 225 from the roller plus 1 over √2 FAD. Using equation 5, the only unknown we have is FAD. So we can solve for FAD with equation 5. It's going to be a negative 318 pounds. We can use equation 5 in equation 4 and get FAB to be positive 225. All right, so in FAD, that negative sign indicates it's in compression. In FAB, the positive sign indicates it's tension. Again, I'm always assuming tension, so I can always say positive is tension, negative is compression. If you start making assumptions up front about, oh, I think FAD must be in compression, then you would be drawing the arrow towards the point, indicating that your assumption was compression. But now it's going to get confusing because now sometimes positive means compression, sometimes positive means tension. So even even if it's obvious that something's in compression, I still recommend drawing it in tension. That way your interpretation is always the same. All right, questions so far? So using free body diagram A, two of our unknowns, two of the forces we've solved for, there's still three left. But we've used everything out of free body diagram A and free body diagram 1 at this point. So the only way to get more equations is to draw more free body diagrams. All right, so now we can move on to another pin and do the same thing. At this point, it's usually easiest to go to the kind of the next pin over, or a pin that's attached to the one we just solved for, because we'll be able to start using some of the answers we already have in the next pin. So I'm going to go to B next. I'm going to model everything that's happening to B. All right, so what forces are acting on B? Yeah.
Force AB.
Right, so FAB, again, here's where you have to be careful. First of all, we're assuming tension, so in this picture, we're saying that FAB goes to the left. It's the same force. It's the same value because the force in the member is constant from one end to the other in a truss. So because it's the same, make sure you name it the same. So this is where the alphabetical order of your naming is going to come in handy, because you might be tempted to say, oh, it's FBA, but FBA, the value of FBA and the value of FAB are the same. So you might confuse it with being a new force. So if you always use an alphabetical convention, then you know, oh, when I get to the equation step, I already know the value of FAB. So it's FAB here, which is also FAB here. Also notice, I already know numerically what the value of FAB is. In the free body diagram, for the internal forces, pretend you don't know, and then later fill in the details once we get to the equation step. So I'm still going to call it FAB in the picture. What other force? Yeah. Right, FBD is going to be up. And lastly, right, FBC, assuming tension is to the right. Right, so those all the forces acting on particle B. So I have a complete free body diagram, so now I can write the equations out of it. So if I sum forces X in picture B, I will get negative FAB plus FBC. Notice again, I'm still keeping everything as variables and basing all the directions based on the free body diagram. So FAB plus FBC is equal to 0. Now I can fill in what I know. I now say, well, I know FAB I found was a positive 225. What's that? For here? It's I'm naming it FAB because it's the same force as it was up here. So I could call it FBA, but I have to realize that the value is the same as FAB. So it's easier if we always name things alphabetically at this step. That way we don't think that FBA is a new variable. It's the same as what we had before. So FAB, I'm going to name it in both places. But right, it does go from B towards A. So again, that way I see I have FAB at this point. I know its value is a positive 225. Now I plug that in here. So now in equation 6, I have negative 225 plus FBC. So I can use equation 6 now. Right up here. So using equation 6, I can solve for my one unknown is FBC. FBC is positive 225. And I can make another equation 7. Summing forces in picture B in the y direction is 0. I'll get FBD. And free body diagram B, the only force acting in the y direction is FBD. Therefore, solving equation 7, FBD is 0. So member BD carries no force in this structure the way it's loaded. All right, questions so far? All right, so again, I draw a free body diagram, I write the equations from it. Once it's kind of used up, I march along to the next point that, by hand at least, is going to be the easiest. We have 4 of our members solved for AD, AB, BC, BD. The only thing we don't know is CD at this point, so there's only one unknown left in our problem. So I have a choice now. You'll notice that there's 2 pins I haven't drawn pictures of, both C and D. But I only need one more equation to be able to solve for all of the members. So at this point, it's up to me. C looks like it's going to be a little bit easier to draw, so I'm going to choose that as my next free body diagram. All right, so what force is act on point C? Right, so from the pin, CX, CY, CX I drew here as positive. It turned out it was. So I'm going to draw that as 450 pounds to the right. Now this is where CY, I assumed was up in picture 1. It had a value of negative 225, meaning my assumption was incorrect. I'm not redrawing anything, but now I have the opportunity to draw it in the correct direction in this picture. So I recommend taking that opportunity. So this was up negative 225, which is the same as down positive 225. I could, in this picture, draw it up and label it as negative 225, and that would be fine. But it starts to get confusing when you have negative numbers here, because it's easy to forget, oh, it's in the positive direction, so I'm adding a negative. It's even worse if it's down and negative, because then you're saying, oh, it's in the negative y direction, but negative. So in net, it's positive.
I thought for the free body diagrams, you wanted us to leave it in variable forces.
For the internal forces, you should. For the external ones, it's okay to use the actual numbers. Yep. So for the FBC and FCD, those I'll leave as variables. All right. So those are the 2 external forces. Again, I chose to, at this point, draw the 225 in the correct direction. Now I have those internal forces from the members. So I have FBC to the left. And I have FCD up and to the left. Again, a 1, 1, root 2 ratio triangle. Okay, so that's my full free body diagram for point C. So again, I can get out my equilibrium equations. If I sum forces in the x in picture C, that's equal to 0. In the x direction, I'll have negative FBC plus 450 minus 1 over root 2 FCD. Now going back to things I already know. BC, I already know, so I'll plug that value of 225 in. So now in equation 8, the only thing I don't know is FCD. So solving FCD, I get a positive 318 pounds. So FCD is in tension 318 pounds. So if I refer back to what I was asked to find, the force in each member and if it's tension or compression, I now have 1, 2, 3, 4, 5 members out of 5 that I know the value and if it's in tension or compression.